So he has more than 15 years of academic and professional experience in the geotechnical, geoenvironmental, and geosynthetic engineering fields. He currently works as a manager for tailings and water engineering at Freeport McMoRan, a copper mining company in Phoenix, Arizona. Prior to joining Freeport McMoRan, Dr. Gupta worked as a geoenvironmental consultant with Geosyntech for 8 years. He also works as adjunct faculty in the civil engineering department at Arizona State University. He received his undergraduate from Punjab Engineering College, Chandigarh, master's from IIT Delhi, and doctorate from University of Texas, Austin in geotechnical and geosynthetic engineering. So today he will deliver an interesting talk, that tailing governance and managed system owner's perspective. So far we are listening from our researcher or professional side. So it will be very interesting to know what this tailing governance or management system means from the owner's perspective. Now I request Dr. Ranjiv Gupta to start his presentation.
Thank you. Thanks, Professor Sarath, and thanks, Lohit, for arranging it, for this opportunity for me to come and present. And as always, Krishna is the one who plugged me into this. Just many thanks to him to give me an opportunity to come and present. And I also just wanted to take a minute to thank Bob, because Bob has been a mentor to me in Geosyntech. And when I reached out to him to present, he was like more than willing, and he's a fantastic speaker. So it's a difficult act to follow to present after him, but I'll try. So I think his expertise is very well known, and I think all of us, I think you guys kind of saw the amount of work he has done in that area, some of the fundamental work specifically. So what I'm going to talk today about is mine tailings management and governance, specifically focusing on engineering design. I think there has been a lot of discussion on engineering design in this setup. So I'll focus a bit more on the monitoring technologies and how they all lead to governance, and try to bring some of the owner's perspective into the discussion. Since the goals of this kind of series was more futuristic ideas, so some of the ideas we are working on internally and something where at least the industry is in North America, I just wanted to share that perspective with the group. And I'm obviously open to questions, and I've left some time in the end to have an open discussion. And I would also like to gauge if there is an opinion about where the industry is within India and where it's heading, and how we can kind of collaborate with the help of the research community and academia. That will be something of interest to me personally as well. So just a quick background. I think Dr. Sarath covered it pretty well, Professor Sarath. I have a PhD in geotechnical engineering, focusing on geoenvironmental geosynthetics engineering from University of Texas. I was an IIT student. I did my master's at IIT Delhi with Professor KG Sharma almost 20 years ago. And did my bachelor's at Chandigarh. Good memories from IIT Delhi. In terms of professional background, currently I do work as a tailings and mine waste engineer with Freeport McMoRan almost for 3 years now. I'm in their corporate technical services team, overlooking the portfolio of tailings dams they have, and coming up with initiatives and how we can improve our governance systems and build up capacities at sites to be managing those facilities better. And prior to that, I did work with Bob at Geosyntech Consultants for 8 years. Had some good experience working on landfills and also coal ash plants, specifically in Montana. I did some of the projects there, and also been doing some adjunct work with Professor Ed Kavazanjan at ASU, which is where I'm based out of. I'm based out of Phoenix, and this is the university which is in Phoenix. So get a chance to communicate and kind of keep my fingers on some of the research and meet students to know what's going on in this field. Just in terms of perspective, so So very high level. I know Bob probably touched on it way more than I would. So I used to, when I was at Geosyntec, we did some coal ash, and most of my experience was in paste side of the business. So basically dry tailings, if you were to like, and focusing on closure of these coal ash plants. And now when I'm at Freeport, I'm working more with slurry tailings. So high water content material, generally thickened a little bit, but mostly very high water content material, which is deposited through. So kind of have some experience on both sides of the tailings side, on the coal side and the mine tailings side. Just a very quick background on Freeport, and specifically focusing on what they have in their portfolio. We have about 76 tailings facilities. 18 of them are active. 58 are inactive facilities. So quite a big portfolio of dams we manage here in our Phoenix team. Sites are primarily in Arizona, a few in Colorado, and one in New Mexico. We have some legacy sites in Tennessee and Texas, and we do have a mine in active mine in Peru, Arequipa, and also one in Grasberg, Indonesia. That's all. So mostly, and I'm based out of Arizona right here, just to give bearing to my colleagues. And this is one of the facilities I typically work on. I've gone into detail on this in one of the previous webinars run by Dr. Reddy, so I'll just touch on it. The tailings dams are pretty big structures, have an embankment and impoundment tailings stream, and then a reclaim pond in the back. So high water content leads to this pond in the back, and then there's a seepage collection in the very bottom of the dam. So typical facilities for copper, low grade copper facilities, these are how the tailings dams look like. And this is one of the dams I work on. So in terms of agenda, when I was trying to put thoughts together for this discussion today, I looked at the program, and I think we were talking about tailings management. And I know a lot of talks have focused on engineering and design. I'll touch briefly on it today in my talk. And I think this is an area where we as geotech, geoenvironmental engineers are very this is our core competence area for something we spend a lot of time on. We go to university, get trained into. But there's another aspect of tailings management, which is related to monitoring and technology. So I wanted to spend some time discussing that piece, like how that can inform engineering and design, and how it's kind of complementary, and something we should, as we are developing programs, whether for research or in industry, to kind of not lose sight of it, or kind of incorporate these into our thinking as we develop our engineering and design side of work more and more. So I'll focus mostly on in monitoring and technology today. Just in general, kind of giving you a high level overview what a governance system from an owner's perspective looks like. And when you are on this side of the business, you're trying to make sure you don't have any catastrophic failures of or unplanned discharges from your facilities. So that's kind of the ultimate goal you're trying to manage to, and make sure your facilities are safe, and you understand what's going into them, and you're managing to that. And a lot has been said about it in global industry standards, which came out in August last year. So that's kind of a good one, which was kind of developed by United Nations, learning from the past experience of some companies which have had dam failures. And I'm sure Horace talk probably touched on that. Mount Pollys in 2014, Fundao in 2015, and Fejao. So that was kind of the response of the investors / the civil society on how these tailings dams should be managed. So kind of laying out some of the very broad guidelines on how these facilities should be managed. And from an owner's perspective, this is what kind of our goals are, and kind of gelling with what is stated in the global industry standards. So just talking really quickly in one slide regarding engineering and design, and touching on some of the opportunities for future. I know this is an area where we spend a lot of time on characterizing the tailings material or coal ash material. I think Bob kind of gave gave the discussion which have happened in around coal ash facilities characterization, and how you can apply engineering analysis. You can adjust design and operations to address any concerns. So something we focus heavily on as geotechnical, geoenvironmental engineers. We're very comfortable in that space. So kind of data collection starts with data collection, characterizing the material, analysis and design. So we, like, a lot of our research or a lot of our training is in this areas. Like, we spend a lot of time as geotechs spending time in field doing data collection, developing models for characterizing these materials. Critical state soil mechanics has been heavily used, at least in the tailings in North America, for characterization. Uh, uh, like work done by Bean and Jeffries, Peter Robertson is kind of on the forefront of that. And then we're developing relationships on how to understand these lab and field data to characterize them, and then somehow come up with ways to input them into analysis and design. And I'm pretty sure Katerina's talk on the models which she has developed, like PM4 sand, kind of touched on that. So an area where we are all I would not say comfortable, but something which all of us spend a lot of time on. Just wanted to list a few of the opportunities which I see in this area. Like, since this material is coarse, sandy, I think anything we can do to push the envelope on undisturbed field sampling would go a long way. Have been some advancement in this area, especially with nitrogen piston samplers. And but yeah, so some of the opportunities, keeping up with the theme of the discussion on the futuristic goals, like any work we do in this area would be helpful. And then more work regarding in lab would be related to stress path testing, like specifically understanding what kind of stress path the soil or the material would go under at the site, and if you can simulate them better at lab during your lab testing, that would basically be something would help a lot for industry. And as I said, like, it's a primary focus of research, specifically going into some of the tailing centers which have come up in last couple of years. So the Tail Lake, which is led by Western Australia, University of Western Australia, Andy Foray, they've been focused on static liquefaction and trying to understand that better. And then the one by Georgia Tech, Tail Inch, they are trying to understand resilience, sustainability, and safety of these materials, but again related to the mining and power industry, but and with the lens of geotechnical infrastructure. And then the last one being the one in North America on Tailings Center by University of Arizona, which is a little bit more broad scope, and they do touch on monitoring technologies a bit, which I'll talk about. But the top two are mostly on the geotechnical material characterization as of now. So what I'm going to touch upon are three main things in the topic on monitoring technology. First is geotechnical monitoring, and then second is the use of satellite imagery and drone survey. As we have kind of gone remote with our site inspections, we've started to rely more on these, and some of the tools for database management. In US, there has been some work done with for highways and trying to kind of bring that software together in terms of DIGS initiative. And so the companies are also trying to do something on their own end for tailings, and some of the international databases have come up in understanding these facilities. So I'll touch on that, like the database or how to manage the data and be able to share to the requisite stakeholders at requisite time, kind of is something where the focus is. And all it leads to is it helps you is having a multi-level oversight and provide an ease of review by internal and external teams and stakeholders. So how all of these come together to kind of help have better understanding of your facility by various people. First, touching on geotechnical monitoring piece, monitoring well and piezometers. I think all of us understand they are used for water well levels and pore pressures. All facilities have some sort of monitoring wells or and piezometer system in and around them. And there is also always something related to settlement plates, inclinometers for displacement measurement. And then you also have a visual kind of an observation piece, which kind of feeds into your geotechnical analysis. You go look at your dam's beach width, where the freeboard is, and understand how much flood capacity it is. So some of the main things we look at among many um, uh, on our tailings facility. Also, kind of touching on the opportunities in this area, most of these sites are pretty remote. So anything we can do to improve the coverage because these are remote sites, so it's difficult to access. So if we can leverage the technology today in other areas, and we have been doing it with the help of wireless communication all around facilities. But anything which we do and push the envelope on this would definitely go a long ways. Where you can have instruments remotely feeding data in a reliable, consistent, timely manner. And I kind of put a note in parentheses, protecting the instrument. Any work we can do to protect the instruments and these remote sites, though they're very remote, somehow the dozers or the field trucks are able to find them and hit them, and we do lose them. So just anything to make instruments more robust or ways to protect them in field also will go a long way. And then I think the next piece is more integrating that data. Right now, the way it is, the data it comes in one kind of a database system. And then if there is a way we can start incorporating that into some kind of stability monitoring directly, that would be another opportunity. And then kind of looking at alerts and data acquisition being triggered, which are accurate and represent things, would be another area in geotechnical monitoring where there is futuristic opportunities. Moving along, I think the next piece is more about remote satellite monitoring. It's definitely become more and more part of the comprehensive monitoring program. Visualizations, and they're mostly used for visualization. It gives you a very quick snapshot of what's happening in time. And helps you identify some of the trends, if there are any you're seeing in readings after readings. If you're taking it over spatially and temporally, you can overlay them and start understanding if they are seeing any movements, or if you're seeing any water ingress or egress out of your seepage out of your facilities. So it's starting to take quite a bit of precedence and use. So there are, having said that, there are opportunities in this area which we need to explore. So there is need for more web-based applications which can lead to easy access of this information, so it can be conveyed out. Somehow being able to overlay this information with your slope stability monitoring or geotechnical monitoring, and creating some 2D, 3D visualization data or deformation data plots, and integrating it with your GIS and temporal data, and then being able to put all that into some kind of machine learning is some of the next avenues, I would say, which are out there for us to go explore and integrate into monitoring of these complex facilities. One more piece I wanted to talk about was geotechnical database management. There's a lot of geotechnical and hydrogeological data which gets collected when a facility is kind of even in its conceptual stage to design stage, and obviously during its operation and closure stage. And then it kind of gets run into seepage and slope stability models, and they are run over the course of the facility. So this is what I'm showing here is a plot by a company called Sequent. It was acquired by Bentley, I think, last week. So they have tried to do, what they have tried to do is come up with a comprehensive way of inputting the data, which is collected from various sources like your geological, geochemical, spatial data, and come up with geological models which are easy to visualize and leapfrog. And then also if you're doing mod flow or some kind of groundwater flow model, integrate those two together, be able to cut cross sections in GeoStudio, and then be able to run the slope, CW, Sigma W facilities with input from your hydrogeological and engineering data and material properties. So the main concept is that you run a digital twin of your facility. So your facility stays is the same facility which is in the physical space is also sitting in a virtual space, and that's all hosted in a platform which they call it Central, which helps sharing the database through various stakeholders. So again, a tool like this or any other which can integrate data from various sources which is being collected and lend itself to analysis and modeling and decision making. It's a very powerful tool, and kind of they have a model which is good, but then there is more opportunities here to refine them, to integrate it with more data sources. So opportunities, again, georeferencing these data sets, compiling your data sets if you are a owner or trying to make sure they're georeferenced. They can map the data maps one-to-one in geological and hydrogeological space. And then if you can integrate all of that together to allow for easy access and review, something which would be of kind of interest to the community. And last piece I just wanted to share here more in terms of analytics and reporting. There was a Church of England investor community had come out in 2019 requesting major mining companies around the world to start disclosing the health of their facilities. So that data was posted publicly by a few companies. And then the Grid Arundel is an organization which took all that data and has basically created an international database, which is available at this link right here. Freeport is one of the has its facilities there too. And when I look at it, we have 313 facilities in North America and 19 in India being reported in that database. So I would say there is an opportunity for us working within the Indian kind of space, Indian research space or Indian owner space, to kind of make sure that the facilities are kind of being made part of the reporting, whether it's in this international database or a national database, to kind of integrate and see if they are being, what kind of monitoring approaches are being followed, and understanding the dashboard for reporting and interpreting those results and helping communicate that result. If you have a central database, it would really go a long ways in understanding it. And I think that that's becoming more an industry standard, I think, overall, where the information is being requested by a lot of companies to kind of, and which is being shared with the communities and the relevant stakeholders. So something to kind of look for. And last thing I just wanted to touch upon was the multi-tiered oversight, what it means in terms of these tailings facilities, whether it's an internal company resource or whether we are working with third-party teams. In terms of company internal resources, generally it goes, I would say, in three major brackets: your senior leadership team, your corporate tailings engineering team, and your site team. So there has to be a very close-knit integration between all these, buy-in from the senior leadership and resources at corporate and site to run these facilities. So you have multiple levels within the company structure to be able to monitor these facilities. And similarly, you have mechanisms on the third-party sides. Your engineer of record, which is probably a consulting company, which manages which works with your site teams on day-to-day basis to kind of a design and analysis and operation to meet operation needs. And then we also at Freeport have a tailing stewardship team, which is a third-party expert team which comes and reviews these facilities on operational grounds every year. And then there is a technical review board which provides more technical design kind of issues with that. So that way you have multiple eyes on a similar facility over the course of a year. to see how they're performing. Just briefly touching on third-party teams, what they look like. Engineer of record, primarily a third-party engineer, works with site on daily basis, and they're continuously trying to improve the process. Like they're always trying to look, okay, how we can improve the management operation of these facilities. Then the tailing stewardship program, they generally are inspecting all the facilities, walking every facility every year, making sure there's a annual independent inspection, independent of what's happening with the site engineers and engineers of record. And they're continuously against the same goal of trying to improve the stewardship process. So more on operations and daily focus on how it's run. But then we also have a tailings review board, which is independent subject matter experts, 30+ experience. This is, and they help us guide best practices and engineering excellence. I think this is a very good place where I would say the academia and industry comes together, where we take researchers to the sites and who have been around facilities, so they can kind of put their research lens on it, and then also we bring industry people who have been around facilities, basically both through tailings stewardship and tailings review board program. A fantastic opportunity to kind of work together. So just to lay out what I did, we started with tailings management, talking about engineering design and monitoring technology, and I've kind of expanded a little bit on engineering design. So we went into data collection, field and lab, some concepts of material characterization, analysis, and design. And I think there are a lot of talks focused on this in this kind of series here. So what I tried to break out a little bit more for the audience here today was on monitoring technologies, specifically talking about some of the opportunities in geotechnical monitoring, satellite imagery and drone survey, and database management, and all kind of lending it all together for a multi-level oversight of your facilities. So having a better governance model for your tailings management. Just two other collaboration opportunities. I'm trying to push our geotechs, geoenvironmental engineers to work with our colleagues in other programs. Like water management to me is one obvious one. It sits in civil discipline, and mines do need water for metal production, and we need to manage water for safe operations. So there are opportunities to work with them in groundwater, surface water, and water balance. And we should, as we are thinking about these facilities and building research programs or future goals, something we should kind of collaborate and leverage their skills in these areas. I think the water management is a big issue at all the tailings facilities, whether it be groundwater, surface water, or just the balancing the water which comes in and which goes out of them. I think something where industry can lean on the academia or the research community is more on the multidisciplinary training programs in field of tailings and coal waste management. And then probably, and I say multidisciplinary, again, with the focus, I think we have good trainings in geotechnical engineering, but incorporating them and making it more tailing specific and delving into seismic hazard analysis, hydrology, and hydrogeology with the lens of coal ash and mine waste facilities would be really helpful as well. So this just shows a picture of one of our site engineers going through a cone tech drilling program. So we brought a drill rig to one of our sites and just spent 2 days in field learning about how the CPT works and working through it and having our teams operate them and understand what goes into it, what data comes out. And this is from one of our TRB meetings. This is Nori Morgenstern kind of working with our site engineering teams, reviewing some of the designs and for one of the facilities. So great learning opportunities. I think learning from the experts, it definitely helps people coming up as young tailings engineers to hear their perspective and gain ideas. This is just my last slide. Just trying to match research and industry. I think the life cycle of these facilities is very long, and it has various components: conception, design, construction, operation, closure, and post-closure. So there are a lot of opportunities. We can leverage technical expertise within industry, and we can combine the work done in academia for mine tailings management. Again, as I said, like there are a lot of opportunities at every stage for industry and academia to combine. And as the theme goes, futuristic prospects for geoenvironmental and geotechnical engineers, I would say that there again. Not only geotech and geoenvironmental, like our traditional fields, but on the side of the monitoring technology, there are opportunities which we should go and explore as we kind of think about these facilities in a holistic approach. So that's it. Open for questions if anybody has any. Thanks.
Okay. Thank you, Dr. Ranjiv. So now I'll request the participants, if you have got any query, please put in the chat box. So before going, so I have got so far 2 queries. So one from Ashutosh Kumar. So his query is, can you please give some insight on the involvement of vegetation in preventing slope failure in the facility where you work in, and best to monitor the same?
So we have not used vegetation for slope failure. And at the facilities I have worked with, because traditionally the mindset has been of water dams, and then if you have been, I think that's kind of the philosophy which was taken initially when the tailings dam work was set up. So in water dams, we don't want the roots penetrating into the embankment and creating pathways for seepage. So if you're talking about embankment slope stability, I would not say we have used vegetation as a mechanism there. If you're saying after closure, post-closure, just to kind of create a surface, that could be an opportunity, but it depends on the size of the facility. And again, I've not worked on the facilities where we have used vegetation as a means of slope failure prevention. So I don't know if I can speak to that anymore.
Okay.
Yeah.
So now the next question is from Sivram Singh. So he asked, is there any change observation in properties of tailings in dry state? How did you get the tailings in dry state, if yes, any specific reason for the changes?
No, good question. The idea is that basically drier. I think all of us understand the drier the soil is, the stronger it is. So I think in the first and the very obvious implication of it is that it's going to probably have a better mechanical response to any loading. And then I think the second question or the second part of this question, how do you get the tailings in dry state? That's a fantastic question, and it's a very kind of area of a lot of work and research, and also to do it at I would say at an industrial scale. So what we do is, like, when the tailings come out, I'm not going to talk about coal, but just the mine tailings in general, or copper tailings, they are unthickened and they have very high solids or water content. So we have high rate thickeners. You can think of these as your, I don't know, lack of better word, washing machine or a centrifuge. So you spin them. You spin your tailings in these centrifuges, and then you are able to extract moisture out of it, and then you leave enough just so that you can transport it out to the through a pipe for deposition. So that's kind of the mechanism. So to get it to a drier state, you generally use a thickener, which are high rate thickeners, which spin it, and then you get the water out and dry them out. So that's the mechanism we use.
Okay, so he has also asked, I mean, if yes, any specific, I mean, when he's saying that there is change in properties dry to wet, I mean, fluid stage, if any change in property, if yes, any specific reason for the changes in the properties of the tailings?
So yeah, so the moisture will influence it, and maybe I can speak to this a little bit more. So basically, if you take water out, you can see the flow mechanism changes. It basically, if it is too much water, it generally flows in a pipe as a turbulent flow versus a laminar flow. So if you are a tailings pipeline engineer, this is where you would spend a lot of time thinking about, okay, how much water I'm taking out of it, because the way the material flows within the pipeline will change. The mechanism will change from turbulent flow to laminar flow. So that's something we need to worry about. And if there's going to be hydraulic jumps, or the way you're going to be managing your facilities. So that's kind of the one thing you have to keep in mind if you're on the slurry deposition or tailings deposition pipeline design side of the work. And if you're on the geotechnical side of the work, the drier the tailings are, as I said, it's probably going to respond better to mechanical forces, whether it be earthquake or anything else. Like, there's not going to be that much pore pressure generation when they're subjected to loading.
Okay, thank you. So one more query. So I'll just finish with this query. So from Luis, what do you think will be the most important contribution of the GISTM for the prevention of tailing dam failure?
I think GISTM by itself is an important contribution, independent of where it is. I think that's a very good question by Luis. So I would say I think the prevention would be in its implementation. As it gets implemented, it will help bring good practices from around the world to different places, like Australia, Canada, US, Europe, India, Africa. Everybody has South America has a different state of practice. So what it will do is at least establish some standard baseline for everybody to follow. All mining companies, irrespective of where they are, like, based in their terms of headquarters, they'll have to follow a common standard where they're operating. So I think it definitely is going to be a very good move in that direction. And then I think it's also has a lot of checks and balance in terms of community engagement. So I think as it starts getting unraveled and people start understanding what's in it and how we can implement it, it's going to have an impact on the industry in a big way. And it's been written with the intention of preventing tailings dam failures. So I'm very positive that it will make a decent contribution.
Thank you very much, Dr. Ranjiv Gupta. So thank you for your presentation and taking all the queries. So now we'll proceed to our next speaker,